Hey folks, welcome back to Clear My Paper, and we are just continuing our episode on the transpose of a matrix. We're going to solve some exam problems. In the last video, I explained you kind of how the questions come on this in the question paper, and let's take the couple of examples that appeared in the last 4 years before the MCQ pattern, and let's solve that. If you understand this anyway in the MCQ also, you have to apply the same logic. It will be still helpful. So I'm going to take one problem that I've solved, and the other problem is already solved in the solutions I've copied and pasted. We'll come to that. So I'm taking the problem for winter 2017, question number 4A, 4 marks. I pasted the question here. So let's see the problem. So there are two matrices that are given, A and B, and we have to verify that AB transpose is equal to B transpose into A transpose. And this, like I said, this is written in the power, but it's not a power, it's just a way of writing it. And sometimes you can also get this A prime or A single dot in the power, right? This is also the same thing. So after I read the question carefully, what would I think? I'll just close my eyes, see and think about what are they asking. So what comes to my mind is, okay, this is like a type 3 problem. I know that this is type 3 out of the 9 categories that I discussed, and they're asking about a simple transpose. And I know what is a transpose, like I've written here. That should be the first thing that should flash in your mind. That transpose is nothing but interchange of rows and columns. Columns becomes rows and rows become column, right? That's what it is. And interestingly enough, right, this is not relevant for the Maharashtra State Board MSBTE, but this thing that they're asking you to verify is a property by itself. It's one of the properties of a transpose. So I'm not sure in other boards whether they have a play on these questions where you have to apply this property and simplify it. But definitely competitive exams like IIT, JEE and all those things, those folks kind of harp on this kind of tricks. If you don't know the property, you cannot apply. And a lot of their problems are revolving around application of that property. It's not about how you solve that. But in Maharashtra State Board, I think this property does not really matter. You don't have to really memorize this for the timing, at least. So that's what the transpose means. So that's the first thing that will ring in my mind, think that, okay, this is something to do with transpose. And like I said, since it's a verify problem, you should never miss out such problems. It's a beautiful, lovable problem. You know that you have to just prove something is equal to something. The left hand side is equal to the right hand side. Your marks are secure. You cannot go wrong because you already know that it has to match. So there is no way that you get lost and get wrong. Even if you do some mistakes, you can always go back and fix it and secure your 4 marks. That's why these kind of problems are beautiful. And as a quick disclaimer in red, matrices are always easier to solve, but they're going to be always time consuming. Most of the matrices problem are always going to be time consuming, and they are prone to calculation mistakes. So you have to be very careful. So when you invest your time on what kind of questions you're going to pick up in the first half of your examination to solve it, always be careful on what kind of problems you want to pick up. I would always say pick up problems like trigonometry as opposed to matrices if you can. Otherwise, if you're careful with your calculation, then matrices is a good choice as long as you can verify the problem. Okay, let's jump into the solution right now. I've copied the question. I've doodled the question over here, which is AB. Our left-hand side is equal to AB. First, you have to take the product of AB and then you have to transpose it. So that's the first step. So what is AB without the transpose? What does it look like? So what I've done is I've taken both the matrices. On the left side, you have A. On the right side, you have B. And as a check, right, it's not required all the time, but as a habit, I always write the order of the matrix. Here it's 2 by 3. And this one is 3 by 2, where the first one is the rows. And you already know that. Okay. And if you see here, okay. And if you see here, what I've done is the columns on the left matrix should always match the columns or the rows on the right matrix. Then only the matrix multiplication is defined or possible. I'm just always verifying that as a quick check. And the remaining two numbers, which is in the double circle in orange, will be if the multiplication is possible or defined. The outer two circles where I've highlighted it, this one and this one, will be the rows and the columns of the final matrix. And we have done that n number of times. Just a quick recap so that you get this mental habit of doing it yourself. So the final order of AB will be 2 rows and 2 columns, right? 2 by 2 over here. Now let's come back to the problem solving over here. Okay, so what does it mean? So I've taken this, and you know that you have to just take this row, first row, and multiply with this column, and so on and so forth, which is what I've done here. Always be careful while you write that. Complete. If you see the spacing, see how much spacing I've given. Take complete space that you want. Write numbers away from each other. Don't get confused with this multiplication and plus sign. Space it out so that you don't have a mistake. First write down all the rows, take one row at a time, solve for the whole row up to here, and then go to the second row, and take it. First write the row, this one, I'll write this one and this one, then I'll put a multiplication sign, and then I'll write the column. So do it your way, but be just careful, because these things could be expensive if you do a mistake. Then it's a matter of simple multiplication and the way you do it normally, matrix this thing. And then finally you get that the product of matrix A and B is this. But our left hand side is not A and B. We want to find the AB transpose, right? That's what we want to find. And what does it mean? What does it mean is that if AB is this, the transpose of A and B put together is nothing but the rows and the columns switched. So this row 4264 will become column over here. So this row over here becomes column, right? And this row over here becomes this column. So whenever you exchange the rows and columns, that's what you that's a basic definition of transpose that we have learned. So the rows and columns are exchanged, and that brings us to the left hand side of the equation, which is equation 1. Now we have to find the right hand side of the equation and try to see if the left hand side is equal to the right hand side. So let's go to the step 2. Okay, what is step 2? Step 2 is the order of the matrices are reversed. That is first B and then A, and each one is individually transposed, and then they are computed, right? Either it could be transposed, or you can use this notation also, does not matter. So here it matters. And like I said, this is a property by itself. So sometimes you can directly apply the property, but I don't think not for at least the Maharashtra State Board. So what I've done is I've taken the given matrices. We have B here and we have A here. One second. Okay, we have B here and we have A here. And the B transpose is again flipping the columns and the rows over here. The rows over here becomes columns and vice versa. Same with A. And you can also see, right, the number of rows and orders will be switched. So over here you have got 3 rows. This is a 3 by 2 matrix. So when you transpose it, it's going to be a 2 by 3 matrix, which is what it is. The rows and number of columns are switched. Same way over here, the rows and number of columns are switched. So now what do we have? So far we have the B matrix, we have transposed it. We have the A matrix and we have transposed that. And the final step is I need to compute B transpose multiplied by A transpose. That means I need to multiply this matrix and this matrix. This matrix will be on the left side, right? Okay, so I've taken this matrix on the left. On the right we have this, and again I'm going to do a simple multiplication. And on the right side I've just made a rough mental note on the same checkpoint, B transpose into A transpose. The order of B over here, if you see, this is a 2 by 3 matrix. I put the order here, and A is a 3 by 2 matrix. And always do a quick check saying that, okay, is the multiplication possible? Are the number of columns on the left matching the number of rows on the right? Yes. So multiplication is possible or it's defined. That check is okay. Then whatever is the remaining outer numbers, the rows here and the columns here, will be the final order of your final matrix, right? And that should pretty much match with your left hand side equation, which you found in the first step, right? So that you also have to remember. And if you see here, I've also copied the left hand side of the matrix which we got in the equation 1. Even this is going to be a 2 by 2 matrix. That means I know that this also is going to be 2 by 2. So far I'm good. I've not done any mistakes. That's just a rough check. You don't have to do it in the exam. If you're confident, keep going. Okay. Now I'm going to come back on the left side. I'm going to do the multiplication here, like a standard multiplication that I discussed with you. And when I find an answer, okay, I do get this final resultant matrix, which is B transpose multiplied by A transpose, and which indeed matches with your left hand side. Sorry, this is the right hand side and this is the left hand side. Okay, there's a typo, sorry about that. So hence we prove that the left hand side and the right hand side are same, and hence the question is kind of proved. Whatever they're asking, we are proving that. If you see here, sorry, my mouse is not working here for some reason. Okay, so that's what this example is all about, right? So we have proved this. And the next example, again, it's the same pattern. If you see here, sorry about the mouse glitch. Okay, sorry about that. Why it's not going? Okay, let me switch it on. Okay, let me see. Okay, why it is not going? My mouse stopped working for some reason. Okay, here we go. So the second problem, right, I've copied, which is again winter 19 problem, question number 4A. Interestingly, both the questions are 4A and 4 marks. Okay, that shows the MSBTE predictability, that you can predict what's going to come. And this is the example. So in the interest of time and for you guys to do the practice, I have not solved it, but what I've done is, for the interest of time, MSBTE does provide solutions for all their problems. So I've taken their solution as is. And if you see here, question number 4A, they have pasted the solution here. We can ignore the remaining part where they are trying to prove this matrix. In this case, it's a 3 by 3 square matrix that they're trying to prove on both the sides. And the same stuff. First they solve for this. You get this matrix. Now you have to make sure this is your equation 1. Then you solve this individually, but you take the B first on the left and then the A and then transpose it, which is what it means. And then finally you have to make sure that your left hand side, which is the equation 1, is matching the right hand side, which is here. Okay, this is your equation 2, and hence 1 is equal to 2, or LHS is equal to RHS, and hence proved. That's what it means. You can ignore this part, right? So that's what it is. So 2 questions have the same logic, pretty easy, but just remember the notes that I've explained on when to do this and how to do that, and I think you should pocket this. That's 4 marks in your pocket, and you can proceed confidently for the next thing. Okay, that's it for this video, short and sweet. I'll see you guys in the next session of Clear My Paper, guys. Thank you. Stay tuned.